All right, moving on to the 3.5 notes, applications of inequalities. All right, so we're going to skip that first page of notes and go into the second page here, starting with word problems. All right, so again, for these word problems, right, as we did with word problems for equations, you got to have to set up your inequality, then solve it, and then write your summary sentence for that particular problem. All right, so here we have the Science Club is sponsoring a car wash at $2.50 per car. We want to know how many cars do they have to wash to earn at least $300. Okay, so again, this problem is an inequality problem because we see wording that is associated with an inequality. All right, and that word phrase is at least. All right, so again, they want to earn at least $300. Okay, so that means that minimally they want to get $300. They love to get more. So then we're going to translate that at least $300 into greater than or equal to $300. So this is going to be definitely part of the inequality that we're going to set up for this word problem. All right, so just like what we did for equations, we need to define what our variable x is going to represent. And since we're looking for how many cars, right, we'll let x represent the number of cars. Now, because it costs $2.50 per car to wash a car, we're going to use that to start writing our equation. So recall with equations, right, that word per means multiplication. So we're going to do $2.50 times the number of cars. So it's going to be 2.50 times x. All right, so now this expression represents how much money they are going to earn by washing these cars. All right, so depending on the number of cars, all right, you multiply it by the $2.50 they're charging per car. Again, this represents the amount of money they are going to earn. Now, because they want to earn at least $300, we're going to go ahead and now put that inequality. So we have, there's a greater than or equal to 300. All right, so the amount of money they're going to earn, 2.5 times x, we want that to be bigger than or equal to 300. All right, so now I'll go ahead and solve for x. I'm going to divide both sides by 250. All right, so when we divide both sides by $2.50, we got x is greater than or equal to 120. So they would have to wash more than or equal to 120 cars to be able to earn at least $300. Example number 2, we got Elvira. She is looking to order milk. The supplier for the milk for the school lunch charges 35 cents per carton of milk, in addition to a delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? All right, so we're going to focus here on budgeted $500 for milk. And when you're on a budget, that means, right, this is all the money you have to spend. So that means you have to stay within that limit. Right, so here Elvira only has $500 to spend on milk. Right, so therefore, she can't go over that when she orders the milk. So that means whatever she's going to spend for the milk, it has to be less than or equal to $500. Right? Whatever she's spending has to be less than that amount. Okay, so we're going to try to write an inequality where we're comparing what she's spending on milk And again, it has to be less than or equal to $500. All right, so again, we're going to define our variable x. Again, because we are looking for the number of cartons of milk. And here we are looking for what is the maximum number of cartons of milk. That's going to be our variable x. Now, in the word problem, we see that they are charging 35 cents per carton of milk. So again, there's that word per, meaning we're going to multiply here with that 35 cents. Okay, so that 0.35 per carton of milk, so it's 0.35 times x. Right, but we also see that there is a delivery charge of $75. So again, in addition, there is a delivery charge of $75. So we need to add that to our milk order. All right, so we're adding $75 to our expression. All right, so now this expression, right, we have written right here, represents what Elvira is going to spend for milk. All right, so it's 35 cents times the number of cartons of milk plus the $75 delivery charge. And what we said earlier, we need what she's going to spend to be less than or equal to her $500 budget. All right, so there's our inequality that goes for this word problem. All right, when you start solving for x, your calculator is going to give you this number. All right, so here we have x is less than or equal to 1,214.2857. Okay, so now because x represents the number of cartons of milk, okay, we cannot leave this as our final answer. Okay, because we cannot have part of a carton of milk. So we're going to need to round this. So now it depends on, the way you round depends on the problem. Okay, so now normal rounding rules say that we should round this down, right? Because this number right here is smaller than 5, we need to round this down. Okay, and that happens to be the appropriate amount here, so we're going to round this down to 1,214. All right, so for Elvira to stay within her budget, she would need to order less than or equal to 1,214 cartons of milk. All right, moving on to number 3. So here we got students who love ranch dressing, so Elvira needs to keep some in stock. Students eat about 2.25 gallons of ranch each day. All right, Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. How many days will her ranch dressing supply last before she needs to reorder? Okay, so we're going to focus on this expression here for our inequality. Elvira wants to have at least 20 gallons left. Okay, so that means the amount left is going to be greater than or equal to 20. She wants to have at least a bare minimum 20 gallons of ranch left. All right, so we're going to define our variable x as the number of days that kids are eating the ranch. All right, because in that last question, it's asking for how many days. All right, that's what we're looking for, the number of days. So x represents the days eating the ranch. Next, we're going to focus on that part of the word problem that says 2.25 gallons of ranch are eaten per day. Each day is 2.25 gallons. So we're going to multiply. We got 2.25 times x. So that's going to represent how much ranch was eaten. So now we're going to look at the part of the word problem that says that Elvira started the school year with 130 gallons of ranch. So she started with that. So how's that going to fit into with our other expression? Well, if she started with 130 gallons and the kids are eating 2.25 gallons per day, this is how we're going to put those together. 130 minus the 2.25x. Right? So we're starting with 130 gallons, and because the kids are eating this ranch, we're going to subtract. So this represents the amount of ranch that's left. We started with 130. Kids are going to eat 2.25 gallons per day. So we're going to subtract that. So we put that together with our inequality. So here is our inequality expression for this word problem. All right, so when we solve for x, notice that because we divided by a negative here towards the end, that inequality symbol had to flip. So now we got x is less than or equal to 48.888 repeating. Now because x represents the number of days, we're going to have to round this appropriately. Now again, normal rounding rule says that we should round this up to 49, right? Because that 0.88 repeating says we should round up. However, if we were to round up, then that would give us too many days for ranch consumption. So for this one, we actually need to round down to 48. So x, the number of days, is less than or equal to 48. All right, so here Elvira has ordered veggie burgers 4 times at these 4 different prices. She wants to stay within her budget. She needs to make sure her average order is not more than $82. So how much can she spend on the 5th order to keep within her average budget? Okay, so not more than $82 means less than or equal to $82. So we need her average order to be less than or equal to $82. All right, so we're going to let x represent the amount that she's going to spend on that 5th order, because that's what we're looking for. Now we need to focus on this, what I have highlighted, the average order. Again, recall how to find the average of anything is you're going to add up all the numbers that you want to average and divide by the number of numbers. Okay, so since here we're talking about the veggie burger orders, we needed to add up all those values and divide by the number of values. So here I'm adding up the 78 plus 72 plus 87 plus 90 plus also x, right? Remember, she's doing 5 orders of the veggie burgers. So we're going to add up all of those divided by 5. This represents the average order. And we want that average order to be less than or equal to 82. All right, so solving that, we're going to add those 4 numbers on in the numerator to start. Then we're going to clear out the fraction by multiplying both sides by 5. And we get x is less than or equal to 83. All right, so in order for Elvira to have her average order stay within no more than $82, that 5th order has to cost less than or equal to $83. All right, so that's it for today. We'll finish up the rest of this lesson tomorrow. All right, please do the assigned problems that are on Canvas. That would be the 3-5 homework problems 1 through 4 only.